This is an example problem that you might see on a test or on your study packet, and it's a pretty typical problem, and I'm just going to talk through it. But at any point, I strongly advise you to try to just stop, look at the problem, and try to work it out for yourself so that you can pinpoint what exactly your weakness is when it comes to solving these gas law problems. So one of the first things I like to do is I like to set up this chart where I have P, V, T, N down the center, and then I have 1 and 2. P stands for pressure, V stands for volume, T is temperature, and N is the number of moles, which represents the amount of gas. Now, basically what we're going to do is we're going to understand that the 1 stand for the initial condition, so how does the problem start off, and then 2 represents the final conditions, what happens after a change occurs. So now what I'm going to do is I'm going to take all these numbers. We have a problem here. It says the pressure on a 2.50 liter cylinder of an anesthetic gas changes from 105 kilopascals to 40.5 kilopascals. What will the new volume be if the temperature and amount of gas remains constant? Well, one of the things that you really need to develop a skill for is looking at the units to determine, is this a unit of pressure, volume, temperature, or moles? Liters is a unit for volume, so we're going to go ahead and include that as the unit for volume. Now we see some new units of kPa. As we read the problem very carefully, we want to make sure we know which one is the first pressure, the initial pressure, versus the final pressure. And since the gas changes from 105 kPa to 40.5 kPa, we're going to go ahead and include that information. We want to know now, what will the new volume of the gas be if the temperature and amount of gas stay constant? So I'm going to leave V2 as a variable. That's going to be like my X in the problem. And what I'm going to do is, since temperature is being held constant, I'm going to cross it out. And since the amount of gas remains constant, we're going to go ahead and cross that out as well. So some of the things that you want to watch out for at this point in your problem is check out your units. Your units for pressure should be identical on both sides of your chart, and we see kPa straight across, which is great. We want to make sure our units for volume are the same straight across, and since we're solving for volume, we're just going to realize that our answer is going to be in liters. And if we actually were dealing with temperature in the problem, we always want to make sure our temperature is in Kelvin, capital K, no degree symbol. And we'll talk about that in another tutorial when temperature is actually involved. But with every problem where you do have 2 pressures or 2 volumes or 2 temperatures, you always want to start off with a combined gas law. It seems like it would be easier to look on the back of your periodic table to find the formula that only has P's and V's in it, which is a good strategy, but what I have found is not every formula is listed back there, so it's always best to start off with this formula. And I think you'll be more successful if you always start with this formula. And with this formula, since we crossed off the T and the N, we're going to go ahead and cross them out of our formula as well. Now we have P1 V1 equals P2 V2, and we're going to plug in our numbers. So P1 is 105 kPa, V1 is 2.50 liters, and we're setting that equal to P2, which is 40.5 kPa, and our V2, which is our unknown variable, like our X. Go ahead and hit pause real quick, solve for V2, make sure that you can do the algebra. It's just simple algebra at this point. And if the units are throwing you off, like the kPa, the L, and the other kPa, just take them off and focus on the numbers. So go ahead and hit pause and solve for V2. If you're ready to move on and you're still not sure how to do the algebra, let me give you some pointers. Since we're trying to isolate V2, and we notice that 40.5 is being multiplied by V2, we're going to do the opposite. And what you do to one side, you do to the other. So I'm going to actually divide both sides by 40.5. I'm just focusing on the numerical value. Really, we're dividing by 40.5 kPa, but that's okay. And when you put this into your calculator, 105 times 2.50 divided by 40.5, volume 2 is equal to 6.48. We also need to include a unit, as always, and since the unit for volume 1 is liters, volume 2 will also be in liters. As for sig figs in your answer and understanding when to round, one of the rules for sig figs is to always look at the, since we're only multiplying and dividing, the rules in sig figs is to, your answer will be rounded to the number that has the least number of sig figs, but it's just a coincidence that all three of the values that we're multiplying and dividing all have 3 sig figs, so our answer will have 3 sig figs.